Hi, everyone. I'm going to throw my video on for just a couple seconds so you can see my face and my marvelous basement office here from Bartlett, Illinois. Hope everyone's doing well today. I'm going to share my screen and take my face off of it and talk to you about what I want to talk to you about today. We have an interesting topic, one of my favorite ones. No, not code. Let me pull up. Yes, we will be talking about this in just a minute, but let me pull up our slides for today. So anyway, great to be here today. Really enjoy anytime I get a chance to do a webinar for NYOUG, and especially with my colleagues from Viscosity, one of my favorite companies that I've worked with and worked for in the past. But today I want to talk to you about if you're an Oracle DBA, maybe you're an apps DBA, maybe you're even an Oracle application developer and you got your fingers kind of stuck into the DBA pie because there's no DBA at your company and you're wondering what future there is for you. Well, I've got good news and I've got bad news. The good news is there's definitely a future. The bad news is you're probably already doing it. You're probably already on your way to becoming a data engineer. That was the bad news, you say? Yes, that was the bad news. You're already halfway there. A little more about myself. I really enjoy traveling and public speaking. I'm an Oracle ACE director, which means I don't work for Oracle, unlike Sean, who you just heard. And I'm an OCP. Also, I've written a few books, co-authored a few with Charles Kim, who's one of the co-founders of Viscosity North America. These days, I'm on sabbatical. What does that mean? Well, I hate the word retired. I'm just not working full-time anymore for anyone. So I spend a lot of my time during the winter in Illinois. And summers in Wisconsin, that's a view of the sunrise, which means I've already been up for 2 hours. When I'm up in Wisconsin, I'm an amateur bird watcher. I've traveled all around the world, always looking for different birds. It's not the big ear kind of thing, but I'm just watching a hummingbird come to my feeder here in Illinois. Amazing creatures. Am I an athlete? Yes. Am I a good athlete? No. These are actual photos. I am the oldest dude in martial arts class. Actually, I'm the second oldest dude. My wife is the oldest dude in our martial arts class. That's me getting my butt kicked by the guy who trained the guy who trained the guy who opened our dojo. Believe it or not. Yes, that was in Israel. And I'm not making it up, at a place called Fight Club. So I can't talk about it. If you're interested in following me, best places to catch me on Twitter or catch me on LinkedIn, or just email me after this presentation at jim@jimthewhyguy. Enough about me. Let me tell you a little bit about a podcast that I do with my friend and colleague, Lidon Amitsi. We do this podcast called Beyond Tech Skills. We drop a new episode about every 2 weeks. We just dropped one with Stephen Feuerstein, SF on PL SQL himself, except we don't talk with people about tech. We don't talk about code. We might talk about our experiences. We talk about the other 2/3 of tech. Yeah, all those people skills that you need, the so-called soft skills that no one really talks about. And when I was starting out, I didn't care about any soft skills. All I need is the code. All I need is the tech. Boy, was I an idiot. Check out our podcast. It's fun. We're going to keep doing this for how long? Until it's no longer any fun. So anyway, some great episodes out there. We talk to everyone from experts on DEI and all the way to psychiatrists. I'm not making that up. If you get a chance, have a listen. It's a lot of fun. Anyway, what are we here to talk about today? Well, if you're an Oracle DBA, a modern one, what do you spend the majority of your time on? Well, most of the time, you're spending time trying to make sure your database is healthy, that it's recoverable. As one of my friends that's in Microsoft MVP says, have you tested your backups this week, right? Backups are no good unless you test them. and you better test them because you want to be recoverable. And security. Security is a big deal these days. A day doesn't go by that we don't hear about some issue, some type of penetration attempt. If you're not worried about that, that might take, if you're an autonomous database, about 30 seconds in the morning. If you're not, if you're on premises, it might take a little longer. You have end users, you have developers, especially if they don't know what SQL is. You're going to spend a lot of time working with them, tuning queries for optimal performance and for efficiency, right? There's nothing wrong with doing that. Everybody wants their code to run faster. If you're not working on those two things, then you're probably in a good spot here if you're working on building better data models, right? And one of the reasons you want to do that is to make sure that the data that's stored within your data models inside your database says is accurate and trustworthy. Why is that so important? Because you want to keep your data sources as pristine as possible so that when it's time to refresh those data domains, you can do it efficiently. What's this concentration on data? Why is that so important? Your new customer base really are data scientists and data analysts. A little more coming on that in just a minute, right? I mean, the days of worrying about, are those transactions being committed effectively? That's not where we are today, right? The massive amounts of data available publicly and even privately are the things that you need to be concerned about these days, because your customer base, in many cases, are data scientists. Not everybody can be a data scientist, though. You know, in most cases, you might need a PhD to be a true data scientist. You might be a citizen data scientist. I've acted in that role. My wife actually volunteers at a local arboretum here in Illinois. She does a lot of work with PhDs, right? PhD students, candidates, master's degree candidates. They do a lot of work with data as fledgling data scientists. You know what? They spend 9 out of 10 minutes a day, 90% of their time cleansing data. And I have a great example or two that I'll share with you. When they're not cleansing data, they're searching for relevant data. And I had a little bit of experience with this recently. I'm working on a presentation for K-Scope 22 in June, coming up in 4 weeks. I've been putting it off, but I have to get my search for data done. I'm actually doing a really interesting presentation on Apex mapping, and I'm using it to the new native map region to lay out maps of where charging stations for electric vehicles should be placed in the near future. And I'm keeping it isolated to Wisconsin. You know how hard it is to find some of this data without paying for it? It's not trivial. And the reason I'm doing it is to build a good machine learning model. Now, in my case, I don't have to worry about this too much, anonymizing my subject's privacy, but I am working for a particular client right now that has a particular set of rules that says, if you present data in this format, someone can actually figure out with a little bit of intelligence, oh, that this record actually belongs to this person. And I've identified the fact that this person doing this activity is this person, right? And it isn't necessarily that I'm sharing somebody's SSN or EIN or whatever it might be. It's that if there's enough recognizable data that it's not sufficiently anonymized enough to protect privacy. And we're not even talking medical data or financial data, right? This is more of a licensing and billing issue that I'm dealing with. What do most data scientists really rather do? Building models, training those models so that they're producing interpretable results for useful insights. There's an old saying in data science, all models are wrong, but some are useful. And that's the key thing, right? I mean, if we're doing this and producing an immense amount of information, or really should say collating an immense amount of information and computing it with a huge amount of resources, computing resources, storage, memory, they better yield something. Otherwise, we're not earning our pay. And it's important to realize that data science is exactly like application development. No way. And by the way, I do see there's a few questions. I will get to them at the end of the presentation because we have a lot to share with you today. For DevOps, right, what are we focused on? It's CI/CD, right? We're capturing data, we're retaining it for a period of time, reporting on that data as effectively as possible. What if our applications have an error? It's almost immediately apparent. If someone goes, I'm clicking the button and nothing's happening. It's pretty obvious. This report doesn't total up right. And it hasn't happened to me often, but I can think of at least 2 or 3 situations where I've had to roll back an application to the prior version. Now, if you're using additionable objects inside an Oracle database, and even better if you're using Apex, right, you can actually roll back to a prior version of the application. It's much easier with especially additionable objects, right? Data science ain't nothing like this. From talking with people that are actually in the field, a little more about that coming up. I actually talked to some folks at Intel about this, right? They don't make anything except memory and chips and storage devices that we all use, right? Crucial stuff. Idea there is a useful model. And remember, all models are wrong, but some are useful, as accurate as possible. And again, extremely complex mathematics. They devour computing cycles, right? And in the worst case, not an application that's not working, but a model that is, for whatever reason, utterly inaccurate. And the two major reasons, I should say, major reasons are underfit and overfit. What do we mean by that? Well, underfit is, I got some training data. It looked pretty good. I created a model. It seems to be working. And oh, no, I do not have enough data. This is a big deal, especially with not including enough people of a different gender, enough people of a different race or of a different nationality, right? Where you don't have a diverse enough population of data. And in other cases, overfit, where you really train the heck out of your model, and man, it looks great, and then something else comes in totally unexpectedly. My favorite example of that, it's not a perfect example, is the chatbot. And I don't remember if it was a Microsoft chatbot or an IBM chatbot that within, I think it was 24 hours, suddenly became essentially a racist spewing chatbot, spewing all types of obscenities. And what happened is the data scientists or whoever built the data for the chatbot anticipated that anyone would use foul language or throw in racial or nationalistic stereotypes into the model. And within 24 hours, all of a sudden, this chatbot became this horrible model of a human being, right? If you will. The most vile things that you can imagine were said by the chatbot. Okay, that's probably a great example of overfit, right? Hey, everything was working fine. So is this easy? Heck no. I mentioned I talked to some folks. I was doing a webinar, actually, a seminar with a bunch of folks from Intel. This is part of some of the newer things I've been doing on sabbatical for an organization called Tech Field Day. We have several different events happening during the year, and I'm a delegate for Tech Field Day, and I get to talk to people from all other companies, small, medium, large, right, about what their new product lines are. Fascinating thing. In this case, I was talking with Intel, and Intel said, we got to get AI and ML into our environment because it provides value. And they did some research and found out that in many cases, projects were failing. Over 80% of AI or ML projects fail. And probably the key reason, or one of the reasons most often cited, is it was tough to deploy. But if you look at the rest of the things that they actually found, in a majority of cases, it had nothing to do with actually finding the data, yes, sometimes, or the model itself, or the algorithms they were using. It was a human factor. And in fact, one of the more interesting cases that Intel built, and I did a really nice blog post on this. There's, I think, even a video out there on our webinar that we did with the folks from Intel. What they found in many cases is that there was shortage of skills, a misunderstanding about which algorithms to use, difficulty finding data, difficulty cleaning data, resistance from people out in the field. I don't trust that algorithm. And it's a really fascinating thing that they try to build out. But one of the other things they found out is sometimes people were trying to kill a mosquito with a sledgehammer, right? All they needed was a report. And so that's one of the reasons that in many cases, AI and ML, which is really all part and parcel of data science, failed because people were applying the wrong tool to the business problem at hand. So one of the things they actually worked on inside at Intel is essentially a process that weeded out those things that went, no, you know what, here's an Excel spreadsheet with the 400 lines in it that you need. Here, that's all you need. You don't need AI and ML because these things are very expensive to deploy. Expensive in terms of resources, but also in terms of time, right? So let's talk about that 90% scourge, bad data. And this is one that I gleaned recently. During the 2020 national elections, I was an election judge. You may have heard me talk about this before. That was my first time. My wife has been an election judge like 9 times, okay? And we, guess what, ran on Dominion hardware. Yeah, and do we have problems with it? No, everything went fine. So that was one interesting thing. But this headline came up off of a website called the Gateway Pundit. Anytime I see anything that talks about fairy tales brought up by the conspiracy media, I'm not sure I always trust it. But this one was interesting, right? It says a grassroots group found 23,000 votes. All those voters had the same phone number. And then in the same county, by the way, this is Racine County, which is just north of Chicago, right? So near and dear to me. They found 8,000 voters that were registered in 1918. All of these people, right? Obviously, there was fraud. Well, what's interesting is if you took the data that they had and ran it through a normal AI ML process and looked for things like classification or clustering, you would see exactly what they saw, right? That's exactly what they did see. Here's the interesting part underneath it. Remember the 8,000 voters that were all registered in 1918? Another curious fact is they were all born on January 1st, 1900. Now, a good data scientist would catch this and go, oh, they also have a registration date of January 1st, 1918. What are the odds of that? Well, here's what happened. Some of you were maybe old enough to remember this election we had in 2000 with George W. Bush and Al Gore. And after 2000, there were major changes. Money was freed up from the government to basically say, let's make the voting system better. So one of the things they did is Wisconsin decided to centralize their voting system. Well, municipalities, especially in rural areas of Wisconsin counties, didn't really have a centralized system. A lot of people might have been just doing an Excel spreadsheet or horror of horrors on paper. So they had to put stuff into this centralized system. And one of the requirements was we need a birth date and a registration date. And not everyone had that data. So you know what happened. You've done this when you've had to fill data in, you know, you go to a website and go, oh, I need put something in, right? They put in a registration date of 1/1/1918 and a birth date of 1/1/1900 because they needed something there. They didn't have the data. What should those values really have been? No. But because the system required something, they put something in. Oh, and by the way, those 23,000 votes with the duplicate phone numbers, an organization did some research on this because, you know, this is a suspicious claim. Guess what they found? The phone number was identical because it was a city of Racine telephone number, because Racine, being a large city, reasonably large city in southeastern Wisconsin, required a non-null value. What do you think when a voter registered and they said, well, what's your phone number? I don't know. I don't want to tell you. Guess what people put in? Somebody said, just put in the city of Racine. It was like, departments of streets and sanitation or something, phone number. Again, a good clustering algorithm finds this. All models are wrong, but some are useful. This one's useless because it's totally wrong. So it's, again, you got to be careful when you make assumptions about this. Okay, so maybe this one's a little politically charged. Let's talk about religion next. I'm kidding. Let's talk about null. I was picking on null. This is a true story. A guy was a hacker, an IT professional, security professional. He thought it would be cute to get a funny license plate. Null. By the way, he and his wife had same cars, different colors of cars, and he thought it would be cute if she got a license plate called or named void. So they could take a picture in their driveway of their two cars saying null and void. Well, he was allowed to register for a vanity plate with the word null. Well, the next year he gets a ticket because he tried to renew it again, and they went, no, I'm sorry. The minions detected the fact that somebody picked null and it was no longer acceptable. States do this all the time, right? They pick data, or I should say names that are not acceptable. Some are, if you pay enough attention to them, or could be obscene or whatever, right? They decided null was no longer acceptable. Everything was still fine until he paid the ticket. Because guess what happened? Guess what people, law enforcement officers, were writing in for license plates when they find a car or a vehicle that was abandoned on the side of a road? Yeah, null. And guess what happened? He got a bill for $12,000 in fines because he was the one that was now being identified. Poor Mr. Tartaro here, being identified as being the person abandoning the cars on the side of the road. Ha, 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 ha. Yeah, not so funny, is it? Let's just take one other case. Okay, you're a DBA or maybe a burgeoning data scientist, and you've been told you have to create a table of patients. And here's some of the attributes. I didn't list them all. Let's talk about sex. Yeah, patient sex. Well, everybody knows we need to put a check constraint on data, right? Obviously, here's one that can only have a few values. And we all know that the check constraint should be M for male and F for female until someone comes along and breaks that rule. For example, what if someone is transsexual? And by the way, in India, in Australia, and other countries, but those were the two leaders, they pioneered the value of X for someone that was transsexual. And one of the reasons, interestingly enough, for India is in Mumbai, India, there are several sex change clinics. It's one of the more popular places for people to go out of country, out of the United States or Europe, for sex change operations. Well, if someone's traveling and they're neither male nor female because they are transitioning, the value X is valid. And what if somebody goes, none of your business? They just don't want to know. They don't want somebody to know for whatever reason. How do I record that? Do I allow it to be null? How can somebody have a null value for sex? Oh, and by the way, we haven't even talked about gender yet, okay? And we're not going to talk about relationship status, okay? Some definitions of gender reach into 3 dozen. We're just talking about one thing here that should be quite simple to define, but it's not all the time. Well, who cares about X? That doesn't make sense. Or who cares if they put a U in there for none of your business or what, unknown? Well, what if you're trying to specifically reach out to those particular people? Or you want to see, are there any outlier data related to that? Yeah, these are all valid questions. Bad data happens because we don't anticipate. what could change in the world, right? I mean, people weren't having sex change operations until the early 1960s. Okay, that's barely 50 years ago. So there's a perfect example. Let's shift our attention to what does a data engineer actually do? Well, I found this drawing. This gentleman, Giuliano Ligori, on LinkedIn, keeps building these excellent slides. And I asked him, I said, can I use this? Because this is great. Look where the data engineer role sits. It's in between data scientist, you know, the genius with the PhD, or the citizen data scientist without the PhD, but smart enough, understands math well enough, and in between the data analyst, right? Yeah, the data scientist has got all the smarts, knows how to program stuff, knows all about math, but from her perspective, maybe doesn't give a whit about what problem the data analyst is trying to solve. And where are we as a data engineer? Right in the middle. We have to understand programming. We have to understand a little bit about mathematics, at least. We have to understand things like why null is important. We better understand how a cloud environment works. And look at all the skills that are listed here. I love this slide. It's perfect, right? Here's something that's interesting. If you take those by color, orange for data scientist, blue for engineer, green for data analyst, here's the skills that are listed. Guess what? If you're a DBA or even a developer that functions as a DBA, you know, a lot of companies don't have DBAs. If you think about how reliable a lot of databases are these days, especially autonomous database, right? Do I really need a DBA? Well, not for keeping the database up, but maybe for data modeling and for other things. Guess what? Here are all the skills that Grigori listed, right? Guess what? What's in the middle? The sharpest tool you already need. You already know. SQL. It's amazing. I was talking with one of my colleagues. He said, yeah, I got a shout out because I did a little bit of training for some analysts and they really like SQL. They had never used SQL before. They didn't understand it. They were building Java code and they were doing joins inside Java. And they're like, oh, SQL makes it so much easier. Wow, I didn't know about where exists. Oh my gosh, right? You already know everything that you need to know as a DBA or even as an application developer and, you know, advanced app dev to do what you need to do. That's the good news. Well, okay, are there any other skills that you might need? Yeah, you might need to go learn a little bit more or refresh your knowledge on statistics and probability, because that's really where everything comes in handy. By the way, that's also handy if you're going to your local casino or going off to Vegas to understand statistics and especially probability. And remember about independent events. We'll talk about that later if anybody has any questions. You should know how your team, your data science team especially, not so much the business analysts, right? But how does your DS team gather data? How do they extract it? Where are they getting it from? Is it from the cloud? Are they getting it via Excel spreadsheet? How are they processing it, right? Are they using Python to do it? Are they using Panda to massage the data and extract it and refine it? And also, it really comes in handy to know how to clean and transform data before they need to. Remember the 3 examples I just gave you? Oh, all the same phone numbers. Not so much. Oh, I've got a license plate named null. Or, what should be the check constraint for sex? Okay. Yeah. If you could get the data cleaner before they need to get to it and know the techniques that they may need to use, but you have several really excellent tools. It's called SQL on your tool belt. And then finally, this is kind of important, right? And this goes back to that whole understanding statistics and probability, is understand, right? Remember, all models are wrong, but some are useful. The way a data scientist defines this is how accurate is the model. And there are many different ways of measuring that built into the machine learning algorithms that we're going to talk about in just a little bit, and the different techniques that you can use to determine, is this model accurate? Am I getting an accurate number of true positives versus false negatives or false positives, for example. Oh, and by the way, remember all that high school math your teacher told you about? Sorry, wetting my whistle there for a minute. You know, all that stuff that you would go, teacher, do we have to do word problems? Teacher, are we ever really going to use this in real life? Yeah, this is the stuff that you complained about. It's all the stuff that you probably forgot since high school or maybe even college. It's this stuff, understanding statistics, understanding probability, chi-square, all that good stuff. And by the way, you're probably going to have to at least understand what Python means and what the different methods are. I've had to really dive in deep on all kinds of things in the past 2 to 3 years because so many of my colleagues are using Python. The good news is I got a cheat sheet for you. I'll show you that in just a minute. And how do you get to Carnegie Hall? You ever heard that story? This young guy, he's late for an appointment. He's supposed to go to an audition at Carnegie Hall, and he's never been in New York City before, and he's running up and down Broadway, and he's trying to get there, and he sees this older guy, and he goes, Mister, how do I get to Carnegie Hall? And the old guy looks at it and goes, practice, son, practice, practice, practice. If you're a core DBA or advanced applications developer functioning in that role, you can start practicing right now. Oracle has a bunch of built-in machine learning algorithms and extremely powerful analytic functions already inside the Oracle database. And I'm going to admit to you my ignorance. I didn't even know these things were here until I started delving into machine learning. And why did I do that? Because I kept going to conferences, and Heli Heskayo, or otherwise known as Heli from Finland, had 20,000 people in their in a room of for 150 people, and they were all talking about machine learning. I said, I better go follow up on this, right? And what's the best way to do this? Read up on it, learn it, do it, build a model, learn how that works, and then teach it to someone else. If you're a mentor, teach it to a younger acolyte. If you're married, teach it to your spouse. You might have to wake up your spouse after you explain it to them, but if I can explain it to my wife, Ruth, and she goes, oh, I get it, and I feel like I've explained it properly, then I think I'm on the right track. And she was a project manager. She was a quality assurance analyst, so she gets the science aspect of it. But if you can explain it to someone like it's like they're a 4-year-old, right? So even a 4-year-old can understand it, then you've mastered it. The cool thing is you can actually practice it. I'm going to go check to see if my environment is still logged in. Whoops, not that one. Hang on, folks. And just make sure, no, that's my slides. Where are you? There we are. I am logged into my autonomous transaction database right now. I should say autonomous transaction processing database. I'm just going to make sure that everything's here. Yep. And what I'm going to do is go into its machine learning interface. In fact, I already have one right here. Hopefully you can all see my stuff. It's right here. I'm already logged into my machine learning interface. I'm just going to go to my home page, and it tells me I have to log in. Of course, hang on just a minute. Let me get logged in. Security is good, isn't it? Sure is. I like security. Okay, so what do I need to do to learn to practice all this? And what I'm going to do here is I'm going to show you something really cool, kick it off, and come back and explain it. So we have more than enough time for it to finish. So let me go back to full screen here for a second. What I've done is created or logged in as my machine learning user. AIML noob. Yeah, I'm a newbie. I don't know anything about this. Assume that's you. What can I do here? I can either create Zeppelin notebooks. And by the way, if I don't know what a notebook is, I can check out some examples. And here's an excellent example. I have not even looked through these in the last few months, but what's really interesting is that Oracle provides you with an enormous number of examples for doing all types of machine learning examples. And by the way, they've added some things here recently. Originally, if I remember correctly, all that was here was OML for SQL. In other words, I can build, for example, let's find one here, a clustering example. And I can build what's called a notebook. By the way, I can take this notebook and copy it into my own project if I want to. So this might take a couple seconds to load up. Let me go back to my slides just for a minute here. So I showed you here creating a user, need a username and a password, an email address. And then I can go in and access different machine learning tools, right? So in this case, I've logged in to my environment, and then I've built using these different notebooks. And these are samples, right? This is actually about 2 months old. This has been completely revised in the past 2 months. I found that out a few days ago when I was going back through my slides, because now Oracle has built out not only OML, Oracle Machine Learning, for SQL. These were all SQL based. They now, as you may have noticed here, if I go back here, this one is based on SQL. Hey, I know SQL. I can do this one. Sure you can. And this is an example of what's called a clustering machine learning algorithm being applied to some customer data. And it's using an EM, or expectation maximization algorithm. Well, I don't know SQL. I'm an applications developer. I don't want to use this one. Okay, no problem. Because you may have noticed, they're also built in or built out exactly. I believe there is one here as well. Yeah. You don't want to do it in SQL. You don't know it that well, but you know Python. Check it out. Here it is. In this case, notice they're using pandas, NumPy, matplotlib, all the stuff that you're familiar with, building a machine learning model right here. It's essentially the same thing, except in SQL versus Python. And by the way, this is a really great way to learn Python, because it has all the code that you need in Python. And guess what? Exactly the same example in SQL. So this is a new addition. I think it's only about 2 months old. There were rumors this was going to be out there right around this time. This is exciting, right? And by the way, you may have noticed that when I open this particular notebook, it's already executing code. It's doing what it should do. And it's already finished different types of operations. So if you don't understand Oracle machine learning or machine learning at all, guess what? You can learn very, very quickly using the examples. Let me jump back to my slides just for a minute. So I showed you this, actually the more advanced aspect of this, but this is something that's uber cool. Rich Nemec's up right after me, and I don't want to cut in on his time. I want to make sure he has plenty of time to talk about what he has. But I just want to let you know, this is almost getting close to a year old. If you have not looked at AutoML, you're missing the boat. The idea behind AutoML is this. Which algorithm should I pick for what I need to model? I don't know. Do I look like a data scientist? Do I sound like one? Definitely not. Right? Do I have a PhD? Well, yeah, I've actually got 2. They're in my garage. They're post hole diggers. You know, those things you dig post, never mind. I do not have a PhD. I barely have a baccalaureate, okay? I can learn using AutoML. I'm going to show you that right now. I'm going to kick it off, and we're going to come back, and I'm going to walk through exactly what I was able to do. So I'm going to come back here. I'm going to go back to my project. I'm going to go to AutoML experiments, excuse me. I ran one this morning, but I'm going to run a new one. And this one, I'm going to create. I'm going to call it Solar Super User Regression. And what I'm going to do is pick a particular data source. Remember, I was talking to you about solar energy, that I'm very much interested in alternative energy and electric vehicles, right? I'm actually working with our current townhome administration. We're talking about putting in a set of solar panels, not on each roof, but southward pointing, that would, for our homeowners association, give us a bonus from our local utility. Not free, but it would turn itself in less than 5 years, right? Instead of doing it all individually. Let's pretend we're looking at a model for a modern public utility, which Exelon here in Northern Illinois is. I built a bunch of data for particular customers that are already using solar energy. And what I've built for them is a model that says, based on their usage of solar energy, if they used at least 15% of their entire electrical consumption has been satisfied by solar energy, by solar panels on their roof, or however they're doing it, I want to consider them a solar super user. So I'm going to pick that particular guy here, solar super user. By the way, it's just binary, 1 if they are, 0 if they're not. And I'm going to use as their case ID the actual smart meter for that solar installation that's monitoring essentially their entire solar, their entire electrical utility usage. And here I'm going to go ahead and I've already done a classification. I'm going to run a regression analysis. And Oracle immediately comes back and says, well, that's cool. By the way, here are the data that I've got for analysis. And I've already done some basic min, max, mean, standard deviation research on it. And what I'm going to do is build what? I'm going to let Oracle with AutoML tell me what models might work. And so you'll notice, by the way, that Oracle allows me to pick a whole bunch of things here to run this particular set of models. And it's going to run a GLM, it's going to run a neural network, an SVM, 2 different types of those. I could pick additional ones if I wanted to. And I'm just going to go in here, and could this be any easier? I'm going to say, give me as quickly as possible a result. And what does Oracle do? What does AutoML do? It goes out and creates what's called an experiment. And we'll see that starting up here in just a second. I see we do have a few things in the chat. I will get there in just a minute. And OML is now going to run through some initialization process, pick some algorithms, and start kicking this thing in the tail and generating some models for me. And you can see that it's already finished selecting the 5 models it's going to use. It's created different model names for each of them. We'll talk about why that's important in just a second. But what I did to actually start this is right here. I built a data source. The one I'm showing you here is missing just 2 pieces, the CF ones, because that data hasn't been loaded and refreshed lately. But those are mainly financial data. Why am I looking at these data besides somebody being a solar super user? Well, guess what? Most utilities give some sort of benefit to a customer if perhaps they're minority owned, or if they've been a long time business, right? And depending on the locale that they live in, right? And so what I did is I built this little table. Took me about 5 minutes to build, less than a minute to create. Basically, they gathered up all of my solar super user data and then started this process. The only thing I really had to do was grant to my AIML noob username, account, the ability to touch T-Smart Meter business profiles. I've already showed you all of this, so I'm not going to waste your time on that. And the different settings that I can create. By the way, I could pick fewer than the 5 top models. I could specify additional ones. I could specify a different model metric. Yeah, the thing that says whether the model is accurate or not. Remember, we talked about finding out the accuracy of this? And told Oracle, rock and roll, baby, faster results. And as I showed you, it's already starting to process this. Let's see how we're doing here. Actually, it's finished 4 of the 5 models. It's working on the 4th model right now. And the 5th model, it's already starting on, right? And again, what is this NMSE? Negative mean squared error. This is one of the metrics that if you're a data scientist, you understand. It basically gives you a rough idea of how accurate your model is. And there's even cooler stuff here that they've added recently to AutoML that I'll come back to. But this is just about finished. It's tuning up the model. And at this point, it's just about done. This will eventually come back and tell me it's completed. And it is now done. And it ran in 2 minutes? What do I need a PhD for? Not too shabby. That finished in less than 2 minutes. Now, again, is it a lot of data? It's 50,000 rows. It's not a huge amount of data in this case, but it's good enough for a demonstration. And here's what's interesting. I'm going to go back to my experiment. Here are the metrics, as we said, right? Actually, I'm in exactly the right place. I'm going to come over to, oh, let's pick this one. Let's pick generalized linear model. And what I'm going to do, by the way, is I can see all kinds of things in here. It's not so much there per se. What I'm going to do is I'm going to click here and say, create a notebook. Remember I talked about notebooks and how easy it was to create from the examples? Here I'm going to take a model that AutoML generated, and I'm going to create a notebook from it. And then I'm going to come back to, not my experiments. Notice there's my solar super user regression. I'm going to go back to my notebooks. And here is my GLM. And I'm going to pop this guy open because my slides are basically almost done anyway. And I'm almost out of time. And I want to answer your questions. This is the end result of AutoML. Here's the notebook. And you'll notice something interesting about the notebook. Guess what? It uses Python. Yeah, by default, it uses Python. And essentially, it's not that hard to understand this, right? Right here, basically, it's building a list of columns from the data to load the data. It also went all the way through here and built a model, selected test data, and loaded that test data directly into the notebook, and then ran the quality results down here. And I could dig into each one of these to share this with you. The point is, and I do have one, how hard was this? How many mouse clicks was that? I mean, besides having to create the data, right? And letting Oracle do the selection and letting it do the work for me. When I did this with a much larger data set, it took about 11 minutes to do a similar regression. Again, I had a little bit more financial data there to look at. It ran relatively quickly as well. I believe it ran in less than 7 minutes to do all of the classification models. And by the way, I can do regressions and classifications inside here. Other things will be available in the future, I'm sure. And I showed you how, once this was completed, to pick a particular notebook, name it whatever, and then run through each of the aspects of the notebook. And so what if you don't know Python? It's pretty gosh darn easy to understand what's going on underneath the covers, isn't it? Finally, to wrap up, it's like anything else. How do I keep a relevant career? Well, why don't you get together with other burgeoning data engineers, data science engineers, data scientists, business analysts. There are organizations out there that can help you with that. Conferences. There are major conferences coming up in the month of June, including Kscope 22. We have a separate track on nothing but analytics, by the way. So that's another place you could check out. And Ascend 2022 and Blueprint 4D, I believe, also have some sessions coming up on that. And you might even want to consider certifying. And you may not be aware of this, but you can actually certify your accomplishments, right? Now, again, this is not the same thing as an Oracle certification, but these are other independent associations that will let you get it accreditation. So again, if you're thinking, maybe I want to go in that data science direction, but I don't have time to get a PhD. Well, accreditations are an excellent way of proving to someone that, hey, I may not have a PhD, but I have put in the time to actually professionalize my career. And I have a couple of links here. I'm not going to waste your time on these, of course, but really the one about the no license plate is hilarious. It was on Wired, by the way, and some other links to some other documentation. And with that, let's go see what our Q&A is. No open questions. Okay, I think we don't have any open questions at this point. Anything in the chat?
Jim, there's
Yes,
one
go ahead.
there's one in the chat. It's a data engineer and a big data engineer. Are they the same roles?
Interesting. I would consider them in general to be the same roles. You're going to have to, as a big data engineer, right, deal with the other clouds that are out there, whether it's Google Cloud Platform, Google Big Data, right, is out there as well. Certainly Azure, certainly AWS. Most of the time, you're going to be dealing with extremely large data sets. Of diverse population. Yeah, I would say, you know, the burgeoning data science engineer in me says, yeah, I would say, I would say 80% overlap. Yeah, this would seem to be the same.
It probably depends
Any
on
other
the
questions?
company. Probably depends on the company too and how they define
I
it.
agree, Rich. I agree. And with that, I'm done. Thanks for
Thank you
listening.
so
And
much.
I'm going to turn this over to Rich.
Thanks, Jim.